Hello students, now we shall start unit 2, which is titled as Product or Service and Process Design and Development Methods. Previously we talked mostly how in unit 1 we talked about how strategically it is important to develop new products or services and processes, and also the strategic importance of commercialization. Now we will talk more about are there any methods, and these methods are basically are observed through world class company practices, and particularly the objectives when you finish this particular lesson is to understand when and how to apply product or service and process development tools or methods, such as the use of project management approach, and then quality function deployment, and the use of concurrent design or concurrent engineering philosophy, or what is popularly known as use of design teams, and lastly the design for manufacture and assembly. Interestingly, they seem to appear as if they are used for product manufacturing. Interestingly, they can even apply equally for service operations like cell phone service design and offering it. So that is why some people call the design for manufacture and assembly as design for operations. So we will spend on these 4 methods in this lesson. As I mentioned, the use of concurrent design teams is becoming very popular. Also treat it as a project management, be it an airport construction or a classroom building or a plant or designing a new automobile car. We got to treat it as a project management. Those two are the approaches, the design team approach focusing on use of teams, and treat as a project management approach. The next two, the quality function deployment and design for operations guidelines, are the actual planning tools to use the design teams in developing new products or services, as well as improving or developing new processes. Now we will talk about these two approaches, namely use of design teams and the use of project management approach. First, the design teams. 2 types of approaches. One is sequential process design approach. The second one is more like the design, concurrent engineering design approach or design teams approach. The sequential process design approach was originally followed all the way through 70s and mid 80s. It is sequential. It is sequential. Basically, you do your job, throw it over the wall. For instance, the field service people and the marketing department identify what the new features that the customers are preferring, make a report and throw it over the wall to the design engineers. Then they design what they thought is the best based on the previous report submitted by the marketing people, and then once their job is done, throw it over the wall to tooling engineers, tools to make the component parts. They design the tools and throw it over the wall to the manufacturing, like this sequentially. What happens in this process when manufacturing people decides the material that the design engineers wants in that product is not really achieving the objectives from the manufacturing point of view, they will send that back to design engineers, which then necessitates the tooling engineers do their job, and conflicts and the senior management has to come in to resolve conflicts. All takes time. Time is money, therefore more costly, and therefore product is delayed to the market. one of the most important aspects of commercialization is not achieved. So, that is what the sequential approach promotes, and as a result the disadvantages are frequent reworks back and forth. Also major engineering changes quite frequently. Manufacturing stage, the product goes back to the design stage, and then all the frequent engineering changes that takes place consequently, and increased costs, delayed market, delayed time to market. So, American industry all the way in the 70s and through middle 80s plagued with projects being delayed, costly, and so the Department of Defense Research Unit could not cope up with the cost, came up with a suggestion of why don't we do concurrently. In other words, marketing people who identify customers along with the design people, tooling engineers, manufacturing people who produce the product or the service, and some suppliers who have the capabilities, all form teams appropriately and work concurrently. When the design engineer thinks a particular component they need, tooling engineers also consulted whether the existing tool can make that component. At the same time, manufacturing engineers are consulted with the material that goes into. All the problems are solved simultaneously as a team, and that is the focus of design team approach or concurrent engineering, which is defined as shown there, a systematic approach to the integrated concurrent design of products and processes, including manufacture and support, the entire life cycle. Not only the product is made, and the product is made and sold to the customer, any problems the customer face while being used, those problems could also be investigated, and corrective actions could be taken when you are designing. So, this is the approach is becoming very popular these days. I am sure the software design engineers form teams with customers and suppliers to design the product, complete it, and then send it to wherever the customers are. And the advantages, enormous. You actually talk to the customer. Interestingly, when Boeing 777 was designed, they used something like 235 teams across the world, across the globe, and their first launching customer is United Airlines, and they got even involved them. So, United got the plane what they want, energy cost savings, and sound not engine sound not affecting the passengers in the plane. All those objectives are accomplished for the United Airlines. They are very happy, and then shortened with teamwork, all people together working, product life cycle was designed, reduced. Actually, they reduced the designing a new plane ready to roll on the assembly, almost 40% of the time was reduced, and product quality is increased. United got what it wanted, and product cost, the cost was reduced as much as 25% of design cost for the Boeing which is designing the plane, and the communication increased between the United Airlines company as well as the design engineers as well as the component manufacturer who may be located in Japan or in Korea, all of them. And with the technology, this is no paper was involved when designing, everything is on computer system using CAD/CAM design techniques to design a new component and therefore the new plane. All that as part of the record and made possible by design team approach. And the next item as I talked is project management approach. When designing this from the beginning to the end, the design cost could run in millions of dollars. So, you got to approach how your cost is progressing as you are designing, as well as how schedule, the completion times are progressing. At the same time, what you are producing this plane, what United wants. all those activities from the design and develop as well as ready to roll into the assembly line, all activities must be integrated and seriously coordinated. And the goal is to produce the product, same as service, to the right product at the right time for the right customer within the resources, namely the cost, the schedule must be completed. So, that is what the unified approach, which is called project management approach. And there are 3 objectives, as we mentioned: the time with which you got to complete this project, and the demand is what? Reduce that time. At the same time, costs are important, because customers want only affordable cost and all the features that they want. Interestingly, even for a building, even for a home you are building, you keep on changing your requirements, and every time you change, it costs money for the builder and the architect. Also, it takes more time. So, when the builder and the architect get together with the customer, thought out very seriously what the future needs that this customer is facing and how to include them when you are designing. And that is what is called risk assessment, which is an important ingredient of project management. When you are designing what customer future needs are, or when this product is at the customer's hand, what kinds of problems that the customer face, avoid them. Interestingly, when you find at the design stage, it may cost one rupee, but when the product is made, when the customer finds that problem, it could cost hundreds of thousands of rupees. So, to avoid those things, you determine what kinds of possible consequences that at the customer's hand this product creates and how to reduce it. That is what the risk analysis and assessment, which is one of the important aspects of risk management. And so, there are so many features. One is integration. As I said, all the activities needs to be integrated. When you are defining the project, exactly what it is, what customers want, what customers could change in the future, and how do we integrate, what are all the people's needs within the organization, the scope, the definition and the scope, you need to determine very early. And then what are all the activities, what the time it takes for those activities. Ultimately, you can estimate the scheduled completion time of the project. And then once you know the activities for each activity, you can associate the cost, you can associate the manpower requirements, all of them can be translated into the cost, the total cost of the project. And quality, customer requirements, as I mentioned, how you identify clearly, and once you freeze the project, no more changes. So, that is how you got to be very, very cautious, very clearly define what the project and the scope of the project. And then human resource needs, how many people you need, what types of expertise are needed, what types of teams of experts you got to develop, how many members in the team, you do not want too many people. All those needs must be addressed. And at the same time, communication, projects completions, stages and reports to whom it should go. Each project may have a sponsor. When do you need to, what type of information you want to send it to him or her. Communication process is extremely important to keep the management above you or the team members working in the team all are on the same plane. Then the risk management, whatever the future risks that could occur because of this product use, you should assess right now when you are designing. As I said, when you are designing, design costs and manufacturing costs will be much, much smaller to avoid that consequence when it is faced by the customer customers while customer is using. So there are so many techniques. One of the very popular technique is failure mode effects analysis. What types of failures? What is the mode that they occur? What are the consequences? How serious those consequences are, and therefore, how to avoid those consequences, designing those corrective plans to avoid those consequences. All is done in project risk management and analysis. And last thing is suppliers. Today's trend is hire more and more of suppliers, because as I mentioned in the lesson 1, suppliers are having more capable. They are having their own competencies. When a supplier has a better core competence, why should you want to develop? You use your resources that are released by giving the work to the supplier to develop your own competencies. So both develop core competencies and work as a team. So that is the advantage. So therefore, procurement of suppliers, the material, all of them relates to this project must be addressed. These areas could be seen as a chart, as an integrated system. That is why project management is gaining more and more importance more recently, particularly in the 90s and the next decade and into the future. The more complex the project is, more important it is that you got to use project management approach. Now we talk about planning tools. As I mentioned, the use of design teams and project management are the approaches. They do not explain how to do, but except use the project management approach by teams. But the planning tools, one quality function deployment, the other one design for operations guidelines, are the tools that are useful while designing the new product, the service or the process by the teams. The quality function deployment basically involves 4 phases. The first phase, product or service planning. The focus here is understanding the customer requirements and translate those into the features to satisfy those requirements. And this is very fundamental, and the voice of the customer in terms of the customer requirements must be heard as what we call in this terminology as house, and then decide what features to satisfy those customers as we call house. I'm sorry, I think the customer features, what customers want, are called whats, and then the features are called house. Those will be determined in a new product or service in this phase. The next phase is configuration of all the parts and components that are needed to design the product with those features to satisfy customer requirements. The third phase focus on manufacturing operations or service provisioning operations. What processes, which suppliers, what methods, what systems that are needed to be developed to produce the product as identified in the first phase and with the component parts configured in the second phase. The last phase is how to produce production operations, the assembly line or service provisioning operations that need to be addressed. Interesting phenomena, these 4 phases, the output of the first phase will become the input of the second phase, and the output of the second phase will become the input for the third phase, and the output of the third phase will become input for the final, the fourth phase, and then output will be determined. So basically using the concurrent design team approach as a project, you start from the design and all the way to the development and manufacturing done as an input output model. this may not be clear to you, but you can see the first, second, third and fourth phases. And this is done systematically, what is called, the Japanese called the house of quality, which is the American translation or English translation. First step, voice of the customers must be heard. What are the customers, who are the customers, what their requirements are, the features that they want, and you identify those as what's. Second, also how important are they on 1 to 5 scale. 5 is the most important, 1 is the least important, those requirements. So, importance, prioritizing those customer needs done in stage 2. Stage 3, you got to understand the competition. So, what you do in this step, bring in the best 2 products and take your old product that you want to improve on with the new features, compare them with the best products, how your features are compared, so that you can understand the market with respect to the identified customer needs, and then develop the new features, which is step 4. What are the new features? Then to use the resources in terms of the features, you assess the correlations between those new features that you identified in step 4 are done in step 5. Step 6, take those features, how important are they in satisfying customer needs? You see, the features must, you include those features in the product to satisfy identified customer requirements in order to understand how important they are satisfying. Step 6. Step 7, prioritize the design features. Not all features have the same equal importance. So, you prioritize so that you can use your resources more effectively. And step 8, now you see the best products have their best processes, benchmarks. Understand how these best products that you identified in step 3, how did they increase those features, the reliability or the quality, so that you can bring in those, understand how they are doing, and then you set your goals for your product for those features, how much to improve. So, these are the 9 steps which are the house of quality, and that is the house of quality improvement. So, that is an important feature. The benefits are enormous. Voice of the customer will be heard, the design teams will be used, fewer, all these advantages you can see, all of them, lower cost, lower development cycle times, and the communication is improved among all the stakeholders, beginning with the customers. So, it is a very, very useful, very powerful, very simple tool to use, and touching all phases, starting from the design all the way to the production. Then these are all the necessary ingredients to support quality function deployment. Now, interestingly, design for operations address 3 major issues: the general guidelines, quality guidelines, and operability, how to produce guidelines. The general guidelines are twofold: designed to target markets. What is your market? What is your niche market? What do they want customers, and how do you produce within the cost? And then develop new products with fewer components, or develop new procedure, a new process with fewer procedures. What happens in this? Costs of manufacturing, costs of assembling will cut down. Also, cost of design with fewer components will cut down. Quality is improved. So, those are the 2 quality guidelines. Customer requirements are identified, as you see in quality function deployment, and then you develop features to include them. And then what the process capability? You heard about 6 Sigma process capability. How do you achieve that? To improve the quality of the product as well as the process, to cut down the costs, and then to bring the best product to the market. And then use standard parts, standard procedures, a lot of advantages. Standard parts, if in the designing a new product, how to use those existing components, you do not have to make the new tools, do not have to come up with a new material. So, you can use them and achieve both the design cost and manufacturing. You could be creative while using standard parts. Some people think standard parts means inflexible, same old old wine in a new bottle. It's not true. Imagine true transmissions, 3 colors, 5 different seating operations, 3 times 2 times 5 different versions of the same automobile to satisfy different customers. You can be creative using standard parts. Component parts are the same, a different color, different fabric, different transmission. See how many. That is how you can be creative. And personalized designs. Basically, if you are buying a bicycle, you sit on a bicycle rather than seeing what bicycle you want from the store. Take all the measurements when you bend, when you move your hands, and how this body, all these measurements will send to the factory and taken from one of the existing design, make the necessary changes, come up with a bike specially designed for you. They are not really designing for you using the same standard components, they are making the bike for you. Such a technology is available. Globalization, the no more hamburgers in China. Now today you go to Shanghai, you go to Beijing, you go to any small city, you have a McDonald's. Why? Because globalization. So, McDonald's takes the same facility, you see the same golden arch, same hamburger, or maybe Chinese flavor, or Chinese soup may be available, but using standard parts. And the next set is operability. These are all the guidelines how easily you can add a component or remove a component, avoid fragile designs because they may break down or difficult to make, more costly, and avoid coming back and forth, one-way traffic rather than coming back and forth takes more time. These are all simple common sense types of guidelines to make it faster. So, when you get a chair in a packet, how do you assemble them in a box? Entire chair cannot be made in a box, put in a box and get it to you, all the component parts, different things. So, these are all the simple design for manufacture or design for operations guidelines are very, very useful, and you can use these guidelines and the planning tools such as quality function deployment as a team and come up with a new product or service.